Good morning, how are you dear students, and welcome again to our session. Today inshallah we're gonna start a new lesson number 2, acids, bases and salts. So inshallah by the end of this lesson we will be able to explain what do we mean by acids, what do we mean by bases, what is the difference between acids and bases, what is the unique properties of each of the acids and the bases, and what will happen when acids and bases react with each other, and what is the product of this reaction, inshallah. So let's start, guys. What are acids and bases? Acids and bases are chemicals that increase the number of ions present in a water solution when they dissolve. So examples, guys, for acids and bases, we have lemon juice and vinegar. Both contain acid, but for example shampoo, window cleaner, and actually most of the materials or the compounds that are used in cleaning contain bases. So how do acids and bases interact with water? If you guys add for example lemon juice to a cup of water, what reaction will take place here, guys? As we know, water is made up of molecules that have this formula H2O. So water is made up of molecules of H2O. So we have 2 hydrogen atoms and 1 oxygen atom. So in any given sample of water, a small number of these molecules break apart to form hydronium ions and hydroxide ions. So hydronium ions, guys, has this formula. Hydronium ions is made up of 3 hydrogen atoms and 1 oxygen atom, and it will have a positive charge. So H3O plus represent which ion, guys? Represent the hydronium ion. And what about the hydroxide ion? The hydroxide ion has this formula OH minus. Okay, so 1 oxygen atom, 1 hydrogen atom, and the negative charge all together will give us what? The hydroxide ion. So if you have a cup of water, as we know, a pure water here, so most of the molecules will have this formula H2O, but some will have a small number of the ions, the hydronium ion and the hydroxide ion, that will produced when some of these molecules of the water molecules break apart. Okay, so once you, for example, guys, add a lemon juice to a cup of water, what will happen, guys? An acid actually increases the number of positively charged hydronium ion when it dissolves in water. So after you add a certain type of acid into a cup of water, a reaction will take place, and this reaction will result in the production of hydronium ion. Okay, so all acids will, guys, increase the concentration of what? Of the hydronium ions, of the positively charged hydronium ions. What about base, guys? You add a certain type of base into a cup of water, what reaction will take place, and it will result in what, guys? Here the number of negatively charged hydroxide ion will increase. So acids always increase the concentration or the number of the hydronium ion, while bases will increase the number of the negatively charged hydroxide ion. Okay, so guys, a water sample contains mostly whole H2O, as we said, molecules with only few hydronium ion and what? A negatively charged hydroxide ion. So guys, let's start with the acids. For the molecules of all acids contain at least what? At least 1 atom of hydrogen. For example, we have a common or popular kind of strong acid called HCl, or hydrochloric acid. So most acids, or almost all acids, guys, in their chemical formula there is at least 1 atom of what? Of hydrogen. For example, we have another kind of acid called sulfuric acid. Sulfuric acid has the formula H2SO4. So sulfuric acid actually has more than 1 hydrogen atom. it has 2 hydrogen atoms, and so on. Okay, so at least all acids should contain 1 hydrogen atom. And now once you add this acid into a cup of water, for example, this hydrogen, the hydrogen of this acid, will be pulled off by a water molecule. It will be attracted by the water molecule, so the hydrogen will be added to the H2O, and it will result in the formation of H3O plus, or the hydronium ion. Okay guys, so again, all acids should contain at least 1 hydrogen atom, and this hydrogen atom, once you mix this acid with water, this hydrogen atom will be attracted by what? By the H2O molecule, and then it will result what? In the formation of the positively charged hydronium ion. What about, guys, what about the bases? The molecules of many bases contain at least 1 hydroxide ion. Many of them, but some of them actually, guys, do not have the hydroxide ion. They do not have the OH minus ion. So when these bases dissolve in water, what will happen to this hydroxide ion? This hydroxide ion will break apart. It will just break apart, and it will release the hydroxide ions into the water. So it will result in the increased concentration of what? Of hydroxide ions. So what about, guys, the bases that do not contain the hydroxide ions? The bases that do not contain hydroxide ions, when they dissolve in the water, they take hydrogens from water. So they will take hydrogens from water molecules and form what? And form the hydroxide ions. So for bases, guys, we have 2 different kind of bases. We have bases that contain hydroxide ions. For bases that contain hydroxide ions in their chemical formula, they will just release this hydroxide ion will break apart, and it will be released to the solution. Okay, but for the bases that do not have the hydroxide ion, what will happen here? They will take hydrogen from the water molecule and form the hydroxide ion. Okay, so guys, this is how acids and bases interact with water. So again, guys, acids will increase the concentration of what? Of the hydronium, of the positively charged hydronium ion, and bases will increase the concentration of negatively charged hydroxide ion. So guys, we have this question here. Locate the hydronium ions in the acidic solution here, and locate the hydroxide ions in the basic solution. So here we have hydrochloric acid, so this is our acidic solution, and here we have a popular type, guys, of base called sodium hydroxide, and it has the formula NaOH. NaOH. So this base actually has what? Has the hydroxide ion. So we have HCl acid, and we have NaOH base. Okay, so and both of them are strong. Okay, so now, guys, here we have the pure water, and as we can see here, pure water contains only what? Pure water contains only the water molecule, which has the formula H2O. So we have here the formula of what? Of the H2O. We have 2 hydrogen atoms, and we have what? 1 oxygen atom in the middle here. So here we have this key that what? That was what atoms or elements do we have here? So guys, the green ball represent what? Represent the chlorine ion. Okay, here we have 1 oxygen atom, 1 hydrogen atom. So here this model represent the hydroxide ion, and here we have 2 hydrogen atom with 1 oxygen atom. And this represent what? The water molecule H2O, and here we have 3 hydrogen atoms with 1 oxygen atom, and this model represent what? Represent the hydronium ion, the positively charged hydronium ion. So locate the hydronium ions in the acidic solution. As we said, acidic solution will increase the concentration of the hydronium ions. So guys, here what will happen once you mix the HCl acid with water molecule. As we said, HCl contains at least one hydrogen atom. Actually, hydrochloric acid contains one hydrogen atom. This hydrogen atom will be attracted by the water molecule. So here, for example, we have the water molecule that is made up of two hydrogen atoms. Once we add the HCl, one of the hydrogen of the HCl will be attracted by this water molecule, so it will result in the formation for the H3O hydronium ion. So here we have H3O hydronium ion, and here we have H3O hydronium ion, and here we have H3O hydronium ion, and so on. Okay, guys, what about the hydroxide ions in the base of solution? As we said, sodium hydroxide has the formula NaOH. So it contains the hydroxide ion, and simply once you add the NaOH to the pure water, what will happen? The OH hydroxide ion will just be released into the solution. It will break apart. Okay, so it will leave the sodium ions, the positively charged sodium ions, alone, as you can see here for the purple balls, and it will form what? It will result in the formation of OH minus. So here is our hydroxide ion, and here we have one more hydroxide ion, and so on. So we can see here that this solution contain actually a number of different atoms. There is sodium ions, positively charged sodium ions, there is hydroxide ions, and there is H2O water molecule, and there is H3O plus hydronium ion, and so on. So guys, an important question here: what is the difference between strong and weak acids and bases? Actually, we usually divide acids and bases into two main groups, guys. For all acids there is strong acids and weak acids, and for all bases there is strong bases and weak bases. So chemically, what is the difference between, for example, strong acid and the weak acid, and what is the difference between strong base and a weak base? Guys, actually the strength of an acid or a base depends on what? It depends upon how many ions it releases into a solution. So now we know that acids usually release what? Release hydrogen atoms, okay, that will be attracted by the water molecule to form the hydronium ion, and bases usually release what? Release the hydroxide ion, OH minus hydroxide ion. So the strength of an acid or a base is not the same as its concentration. There is no relation between the concentration of the acid and the strength of what? The strength of this acid or base. So dilute hydrochloric acid, for example, is still strong and can damage your skin, but concentrated citric acid doesn't harm your skin. So why? Because actually hydrochloric acid is a kind of strong acid that even if you dilute this hydrochloric acid, it can still damage your skin, and it still will be harmful to your health. But for example, citric acid, even if you are using a concentrated citric acid, this concentrated citric acid cannot cause you any cannot cause you any damage, or it will not harm your skin. Okay, so guys, the main, as we say, the difference between a strong acid and a weak acid is what? Guys, in strong acid, all the acid molecule, for example, let us consider the hydrochloric acid as an example, the HCl. All the hydrochloric acid molecules, all the HCl molecules will break apart. So the molecules of strong acid break apart completely. So all the HCl will release their what? They will release their hydrogens and their hydrogen atoms to the solution to form what? To form hydronium ions. Okay, but for weak acid, actually only small number of weak acid molecules will break apart. So we will have what? A small number of hydrogen atoms that will be released into the solution, and this will result in what? In forming what few hydronium ions. So again guys, for strong acid, all the strong acid molecules will break apart, and it will result in the formation of what many hydronium ions, while for the weak acid, only a few number actually of the HCl molecule will for example, it's not for HCl, HCl is strong. For citric acid, for example, few molecules of the weak acid will break apart to form a few hydronium ions. Okay, so guys, we always say that strong acid will completely break apart, while for weak acid they will partially break apart. The concentration of hydronium ion in strong acid is so high, but for the weak acid the concentration of hydronium ion will be low. Okay, so the same guys is for the bases. All of the molecules of strong base break apart completely in water to form hydroxide ions. Okay, but for weak bases, they will not break apart completely into ions. They will break apart partially, and they will result in the formation of few hydroxide ions. So guys, let's study the following image in order to understand the difference between strong and weak acids and bases. So the question is, how do strong acids and bases behave differently than weak acids and bases? So let's start with the acid guys. Here we have HCl, or the hydrochloric acid, which is a kind of strong acid, and here we have the acetic acid with this formula, which is a kind of weak acid. So as you can see here guys, this is the formula of the HCl, and this is the atomic model of HCl. We have one hydrogen atom and one chlorine ion, okay, or chlorine atom. So now once you add the HCl to the water, what will happen guys? As you can see here, all the hydrochloric acid dissociate, all the hydrochloric acid break apart, and it releases its hydrogen atom. The hydrogen atom will be released, and it will then be attracted by the water molecule to form the hydronium ion. So guys, here we can't see any more hydrochloric acid. We only can see hydronium ions and the chlorine ions. So that's why we call this strong acid. Why? Again, because this acid completely break apart. Okay, but for example, for acetic acid, let us see, after you add acetic acid into this beaker what happened guys? Only one acetic acid molecule breaks apart, and it released its hydrogen atom that is attracted to the water molecule. So only one acetic acid molecule breaks apart, and it results in the formation of one hydronium ion, while the other three acetic acid molecules didn't dissociate, or didn't break apart. So as you can see here guys, the main difference between strong acid and weak acid, that strong acid will result in the formation of many hydronium ions. So here we have 4 hydronium ions, but weak acid will result in the formation of few hydronium ions. As you can see in this beaker, we have only 1 hydronium ion. Okay, so guys, the same is for the strong base and weak base. We have NaOH, sodium hydroxide, as an example of strong base, and as you can see here, this is the sodium, the atomic model for sodium hydroxide. This is the sodium, and this is the OH minus group. Once you add the sodium hydroxide into this beaker, what will happen guys? All the sodium hydroxide, as you can see, breaks apart. So it completely breaks apart into what? Into sodium, positively charged sodium ion, and negatively charged hydroxide ion, and result in the formation of 4 hydroxide ions. Okay, what about the weak base? We have ammonia, NH3, with this atomic model as an example of weak base. So here, guys, we have only one ammonia molecule breaks apart, and it results in the formation or in the production of 1 hydroxide ion and one ammonium. So now we as you can see here, the concentration or the number of the hydroxide ions in this beaker is small, like we have only 1 hydroxide ion, but in the strong base here we have like 4 hydroxide ions. So the main difference between the strong acid and weak acids and strong base and weak base is that for strong acids and base, they will always completely break apart, and they will result in the formation of so many hydronium ion and hydroxide ion. But for weak acid and weak bases, they will partially break apart, and they will result in the formation of few hydronium ion and few hydroxide ion. So guys, what are the physical properties of acids? Acids taste sour. However, you should never use taste, touch, or smell to identify an unknown chemical. Of course, for your safety, since some acids can damage body tissue. Okay, and guys, be careful that most strong acids are poisonous. Okay. Another property, guys, for acids is when a strong acid is dissolved in water, it breaks apart and forms ions in solution. The ions make it possible for the solution to conduct an electric current. So acids has the ability to conduct electricity. Okay, what about, guys, the chemical properties of acids? Acids are corrosive. Corrosive means that they can react with and destroy body tissue, clothing, and other things. Okay, number 2, guys, acids react with certain compounds called acid-base indicator, and these they would cause the indicators to change their color. So, for example, the most common indicator that we use to identify acid and base is the litmus paper. Litmus paper is a type of indicator. Blue litmus paper turns red in the presence of an acid. Okay. What about the physical properties of bases, guys? Bases taste better. However, you should never use taste, touch, or smell to identify a base because many bases can cause burns. Okay. So number 2, bases feel slippery. And you remember we said that mostly bases can be found anywhere in all the materials that is used for cleaning. Okay, so if your hands feel slippery while working with a base during a lab activity, immediately rinse your hands with water until an adult. Okay, so like acids, solutions of bases conduct an electric current. So both acids and base have the ability to conduct electricity. Okay. So what about the chemical properties of bases? Guys, bases are caustic. This property means that they can burn or corrode other substances, and bases also change the color of the acid-base indicator. But here, guys, the red litmus paper will turn into blue. So bases will change the color of the litmus paper from red to blue, while acids will change the color of the litmus paper from blue to red. So guys, let us talk a little about a neutralization reaction. What is a neutralization reaction? A neutralization reaction is the reaction between an acid and the base in a water solution. So when you mix acid with base, this type of reaction is called neutralization reaction. Okay, So the main two products, guys, of this reaction are what? Water and a salt. So neutralization reaction is a reaction between acid and base that will result in the formation of water and salt. Okay, guys, a salt is an ionic compound that forms from the negative ion of the acid and the positive ion of the base. So again, guys, the neutralization reaction is a reaction between acid and base. It will result in the formation of salt, which is an ionic compound, and it will result also in the formation of a water molecule. So the identity of the salt that forms in a neutralization reaction depends on what? Depends on the identities of the acid and base. So for example, if you are mixing HCl with NaOH, the type of salt that will form is NaCl, or what we call sodium chloride, or the table salt. Okay, so guys, what is the uses of these salts? Salts have many uses in industry and in homes. Sodium chloride, for example, NaCl, is used to make baking soda. For example, sodium nitrate, another kind of salt that preserves food. So guys, another examples of salts, we have calcium sulfate and we have calcium chloride. Calcium sulfate, for example, is used to make plasterboard, which is an important component in the construction of homes and buildings. For example, calcium chloride used to help keep ice from forming on roads and sidewalks in winter, and so on. So guys, that's all for today. Thank you, and see you inshallah next week.